This lesson is about optimization with linear programming. We're going to look at 4 graphing bounded regions where the equations are all given to you, and then 2 application problems where you will make the equations. And let's go back and start with the first one. As I do each one of these, I will pause for a few seconds so that somebody can do it on their own if they want. They can stop the video and do as far as they can, and then see how to do it. Your choice if you wish to do that. You don't have to do that for any of them, or you can do that for any one of them you want to. So the first one. For this bounded region, we have these equations. We're going to do 2 things. We're going to graph these equations first. So first thing, put them each here on the line. X greater than 5. So if I look at 1, 2, 3, 4, 5, I'll use the ruler that comes with this. 1, 2, 3, 4, and 5. So that's one of them. And X is less than or equal to that. So we'll shade less than that when we need to later. Y is less than or equal to 4. So we're going to go up to 4. Here we are. If I can get this to stay, we can get a nice 4 on it. About as close as I think we can do right now. All right. Now it would be nice maybe if we were to do that over it in green. I'll do that one different. Okay, so this one's in green. Make a nice arrow for that. This one's in blue. That's sort of a better look for the. Sorry, I don't know why it's not cooperating. There we got that one. Now we'll do x plus y greater than 2. I would like to write that one in y equals mx plus b form, because that would be easier to work with. So it's y greater than or equal to negative x plus 2. So that means we have a y-intercept of 2 and a slope of negative 1. So points on it will be here. Put one accidentally down there. Move this down. Point there, and a point there, and a point here. Okay. So we have this area. Remember, as you've seen with my doing these graphs here, that I require people to put arrows and to draw all the way through a graph. Now, a shaded area for this will be the areas that are less than the blue line, below the green line, and greater than or equal to this line. So this area here, I think I can make this. Oh, well, we'll do enough for this. I can make this a larger thing to shade with, but it's not that large of an area. All right, so this shaded area here will be these are the places that fulfill all of those requirements. And it even continues up to here. There, that's good enough to show that those areas are being counted there. Now, from that area, we can find where it is optimized, where the minimum value or maximum value. Maximum value is usually optimized, but in this case, we're going to look for, you're asked for in a number of problems to find the minimum value, the maximum value. So what we're going to pick are the vertex points. So let's put here, here, and here. So those points, if I had drawn it best, okay, well, let's see what we get to here. Now, because actually I realized this black line, okay, -1, that should have been about here, and that should have been about here. So that line is a little bit off, and I realize that if I start looking by slope. But that means that the point that's right here is -2, 4. The point that's over here is 5, 4. And the point that's down here is 5, -3. That one turned out okay. So with those 3 points, we're going to come over here and enter them. Negative 2, 4, 5, 4, and 5, negative 3. This is the equation 3x minus 2y. We're going to put those numbers in for both. 3 times negative 2. It's got to cooperate a little bit of that, minus negative 2 times 4. So that gives me negative 6 minus 8. Negative 6 minus 8 is going to give us a negative 14. When we do the same thing, let's see how far I can get setting this up for all of them. Same thing for all of them. In this case, we'll put 5 and 4. This one 5 and negative 3. So that's 15 minus 8 is 7. This is 15 plus 6, which is 21. What that tells us then, here is the maximum value, because it's the largest of the numbers, as the result of the function equation that we're given. Sooner or later, I'm going to get a red circle around this. And this one, then, because it's the smallest of the results, is the minimum value. So what you do is, number 1, graph, including the shading, and then number 2, fill out the table, and then number 3 is determine the maximum and minimum. Easiest done, 1, when you have the answers there for it. All right, let's look at a second problem. If you wish to do this on your own, go ahead and do that now. In 5 seconds, I'll start talking again. All right, so now graphing this. When you have this top type of problem, one way to do it is to separate as 2 separate ones. Y is greater than or equal to. Let's make it so that's more easy to see. Greater than or equal to negative 17, and y is less than or equal to negative 5. For many people, that's easier to work with. I'm one of those people where I find it easier to work with. I realize now, looking at this too, I'm going to have to use numbers that go past 10 because I'm going down to negative 17. So what I'll do is I will show here that this is going to be 20 and negative 20. I don't know if I need to do that on the side ones on the x-axis, but it won't hurt to do that. You don't have to have it the same, but it does usually work better if they are the same. So I'll go out to 20s, and then if some numbers are beyond it, we'll estimate that direction. So let's look at negative 17. So negative 17, this is negative 18, negative 16. So that means we'll have a line. Okay, that's about here. And that will be approximately y greater than or equal to negative 17. And then we also have less than negative 5. So it'd be 2, 4, negative 6, negative 5 would be about here. Okay, oops, that one away. That's y less than or equal to negative 5. So the area in between would be shaded, and we'll wait till later to do all of that. Then we have y is less than or equal to 3x plus 19. All right, here's 19. I'll use green for this one. Okay, and the slope is 3. Well, going up and over is hard. So here with 2s, I think if I go 6 and 2, that would probably be easier. Now 1, 2, 3. Oh no, this would be 4. 5. This would be 6 and over 2. So 1, 2, 3, and over 1 would be about here. So 1, 2, 3, about there. 1, 2, 3, and about here. So 6 and 2 would be easier than the 3 and 1. Okay. So 1, 2, 3, that would actually be 6. So let me rethink it. 3 and 2, that means this should be here. That's why when using it with doubles like that, they think it was 1.5 in there, and then 1.5 and 1, so it'd be here. 1.5. Okay, I have enough to work with to make a line now, I think. Especially since I have the two intercepts now. Let's see if I can get them to be in the same spot. Sometimes this ruler is not quite as responsive as I'd like it to be. And I might have to do it by hand if not. Okay, I think that that'll work okay. All right, so that was this one. And that's an arrow here and an arrow here. And that's less than. So less than is going to be all the areas down here when we're done with it. Now let's use red for the next one. Out of the way. And of course, blue is the first one here. Okay, back to the red one. So this one is 8x minus, oh no, negative 4x plus 15. I said the wrong thing. So 15, 2, 4, 6, 8, 10, 12, 14, 15 is going to be about here. And it has a slope of negative 4. 1, 2, 3, 4, and over 1. It's going down 4 and over 1. 1, 2, 3, 4, and over 1. Because it was halfway there originally. 2, 3, 4, and over 1. 1, 2, 3, 4, and over 1. About there. Okay, well, now let's see. Oh, I think, did I miss one on here? 4 and 1, 4 and 1, 4, and that one should be halfway there. Okay, good thing I looked at it again. It's always worth double checking slopes and things because I did notice that line probably wasn't going to be the same. So 2 and 1, 2.5, 2.5 there. 2.5, 1, 2, 3, 4.5. It's going to be about here. Okay, that'll make a bit of a difference. Now we'll put the ruler on that. Lining it up. Come on. That looks okay. Got it while I can get it there. All right, now that one is a less than. So if you put 0, 0 in there, you can see that that's going to make it 0 less than 15. This green one, if you put 0, 0 in there, you see it's 0 is less than 19. Both of those are true. We're to see with the y's that we're between negative 17 and negative 5. So that means our area, that's the black one for it. What do you mean here? Okay, I won't go too much on these because it's pretty clear that this is the area to be counted. Now that tells us the vertices are the ones we count on this. Okay, so when we look a little more closely at where the vertices is, this one should be meeting at about here, which is 2, 4, 6, 8. So that one's 8 and negative 17. This one's going to be a negative 5, but it's also at, looks like about 5, negative 5. 1, 2, 3 is 1, 2, 3, 4, about halfway. So that one's at 5 and negative 5. This one over here looks like it's at, is that negative 2, 4, 6, 8 and negative 5. And this one down here, if that's 8, 10, 12, that's supposed to be coming over about here. So that one's 12 and negative 17. Okay, 8 and 12 and negative 17. Yep, that looks about right. It's negative 17. And that line, green line, should have been over there. If you continue these down, it should have been at that one. Okay, so let's write these down. If I can get that. Sooner or later, I'm going to get an 8 on here. There, finally. So, oh, that's supposed to be a negative 8. That's why I looked at it and thought, no, okay. So negative 8 and, oops, negative 5. Let's just clean this one up, and hopefully it looks a little better the second time. Negative 8, negative 5. Then we have 5 and -5. -12, -17. 8 and -17. And this one is given to us, what we figure out. So if we do -8 times 8, we get -64. And then -3 times -5 is +15. This one's going to be 40 plus 15. This one's -96 plus 51. 64 plus 51. So 114, -45, 55, and -49. So here we have our minimum value. And here we have our maximum value. And those are our answers. We're to find the maximum value and the minimum value. Okay. So graphically, you get the vertex points that you put on the table. All right, next problem. All right, let's look at this bounded region. If you wish to do this yourself, please go ahead and do so, and I'll start it in about 4 or 5 seconds. All right, now let's look and go through it. Okay, x greater than 1. Okay, here's 1. Looks like I don't need to make this by 20s. Ooh, I meant to do this one in blue. I always like to do the first one in blue for some reason. Not sure why, but in that case, let me just go back to all of it. Blue. There, that's the blue one. Arrow, arrow, and a check to show that one's the blue. Then I'll do green for y is 0. Well, that's an easy one. It's right down here. It's the x-axis when y is 0. Okay. Arrow, arrow, and check. And then I'll do red or black. I'll do black and put the red one and use the red one as for the vertices. Okay, so that one though, then I need to change. I don't have to change around, but it's easier for me if I do it as a y equals mx plus b, easier to graph it. It's y less than or equal to, it doesn't change the sign with the 2x coming over here, -2x plus 6. Okay, that doesn't look great for that, so I have to rewrite that just to make sure there's no confusion over what it is. Less than, well, that's if the pen cooperates. Less than or equal -2x plus 6. 1, 2, 3, 4, 5, 6. Slope of 2, up 2 and over 1, down 2 and over 1 that way. That one, that one. All right. Now enough points that I should get the ruler correct. First time setting it up this one. Okay. And put the ruler away, put an arrow and an arrow. Okay. So less than, if I put 0, 0 in there, 0 is less than 6, this part in the middle. The other one, this was clearly less than 1 and greater than 0. Oh no, it just disappeared on me. Come on. Can I get some of that back? No, let's just do it more. Hopefully it'll stay this time. Okay, there we are. The vertices. All right, and it looks like this one is at, well, let's see, 1 and, did I go too far with 6? I don't think I did. Ooh, I think I did something wrong, and I think I just realized what I did wrong. I don't know if anyone watching this caught this, but I realized what I just did that wrong. Slope is -2. It is not this one. It is going this way. Okay, 6 going that way. Woo, big difference. Okay, and it's greater than, not less than. So I just realized those differences. Let's fix some of these. I can just redo it. It would be really nice in math and in life if we could just redo something completely. I can do that on this program. Yay! I missed the slope as a negative. So that means I'm at 1, 2, 3, 4, 5, 6. And negatives means down 2 and over 1, down 2 and over 1, down 2 and over 1. This is a lesson for anybody and everybody, that anybody can make a mistake with it. If you pay attention and catch it during a problem and can fix it, good for you. And that's what I'm glad I was able to do in this case. Oops, don't want that moving, so see if I hold this differently. It'll stay. Okay, let's that away. Now, that's 2 errors I made. The second one I didn't realize till I saw that there. But for this first one, it's a greater than. So that means we're above the blue line. We're also above the green line, but we're less than on the black line because 0, 0 would, and then we'd shade this area and prove it was 0, 0. So this is the area. Now that tells us our vertices are these. Okay. So we have 3 and 0 for this one, 1 and 0 for this one. Okay, I want that blue line back there. That's better. Okay. Arrow to that. No, that one. Little arrow showing that goes to that one. And then this one looks like it's 1 and 4. So those are our 3 that we will use. 1 and 4. 1 and 0. 3 and 0. And it doesn't matter one bit which order you put these in. So if I were to do this one, I'm going to get 3 plus 4. 7. This one, I'm going to get 3 plus 0 for 3. This one, I'm going to get 9 plus 0 for 9. All right. Now, the next problem is the same idea. It's a little more complicated because it has an absent value in it, and there's 4 different ones. So let's look at it. And if you want to, go ahead and work on this yourself right now. Come back to the video whenever you're done. All right, now I'm going to go through these. So an absolute value, you know, is always going to go like that. And I'll do this one again in blue. My first one's always in blue. Okay. So we know it's going to be an absolute value. So for graphing it, we have a couple of ways. We can do like you've done on anything, or we can recognize that what this does is, since there's no multiplier here, this is a simple normal slope of 1 each time, where it's moved over 1 degree, 1 unit to the left, opposite sign of it, and then 2 units down. So that means that the vertex of this will be over 1 and down 2. So the vertex is here. And because it's a normal absolute value with no change in the shape of it, because there's no number multiplying out here, that means it's going up by 1 each time. And then this one's going up by 1, 1, 1. Be easier to place the ruler in the right spot if I can get it to those numbers. And it's a greater than. If I were to put 0, 0 in there, I would see that it would be 0 greater than -2. That is a true statement. So it would be above it that we would shade, but we won't shade it yet until we get the other ones in. We would stay at this point and on that point. Come over here. I stay at that point and move it just a little. Doesn't always cooperate to get the right degrees. This time it did, okay. Arrow here and arrow here. Now, y is between 0 and 6. So we'll focus on the y is less than the 6. All right, 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. New section 1, 2, 3. Hard to number these. Okay, but this one's going to be in green. 1, 2, 3, 4, 5, 6. That's where I need to be. And above 0. So no, I don't really need it on one hand. It'll be a reminder to me if I put that across here. Whoops, if I can get it back in place. Can't quite get it right. There, now I got it right. So these are here. Let's get those arrows. So this one is y less than or equal to 6. This one's y. Let me clean it up on those. Y is greater than or equal to 0. And of course, this is the absolute value. So I'm just going to put, I think I need to write that one, or I'd like to. Let's look at the red. The next one, I'll do red or I'll do black for that one. Here, x is greater than -6 or less than 2. Okay. So x -6. 1, 2, 3, 4, 5, 6. So it looks like we're there for that one. 2, 3, 4, 6, and the other one is 2. I know one of the things some people are thinking is this is tedious. You know, graphing is, and I'm faster graphing. Well, you probably are. So feel free on your own to graph a lot faster, but just be careful with it. One problem with something being tedious, even though I agree it can be, is sometimes you can sort of lose focus and not do it quite as well as you should because you're trying to rush through it because it gets too easy. I understand. Just try to be very careful because much as you want to be done with it quickly, you don't want to make a mistake. So just be careful. So the x's, so we're in between here, we're in between the green, and we're above the blue lines. So it looks like right now we're looking at these areas here, but we have one more to do. So for this one, it's much easier to, in my opinion, personally, to change it around to make it a y equals mx plus b slope-intercept form. And if you do, you get this. Y is less than or equal to -1/3 x plus 14/3. Remember, it's sometimes safest to put a fraction in parentheses. It's actually a -1 to make sure that it's not mistaken for the x being with 3 on the bottom. I guess I'll just write it carefully and they're different. 1/3 and a nice big x, so you can't mistake that as going with the 3. You can mistake that as a 7 though, so let's rewrite that. Okay, so 14/3 is 4 2/3, slightly under 5. Those would be better thought of as just slightly under 5, especially when graphing, because you can't get like a 2/3 exactly. 2, 3, 4, 5, so slightly under. Okay, so that's where y-intercept is. Now then, that means -1 and 1, 2, and 3 would put you about here for the 1. Okay, so that makes this sort of a weird run through, but up 1 and 1, 2, 3 to go about here. So with those points, I will try to make a line. See if I can isolate it a little bit better. This may be okay. All right, now let's look at our vertices. So the graphing doesn't always get you right to the vertices, but you can tell if this one was down a little bit further, I think we would have a point here. Okay, what's that about? Oh, but wait a second, now we need to see where we're going here. I just realized we're in between certain ones. That one's not going to be a good point because we know that this area, we're in between here, and we're going to here. Oh, but can't go above that green part there. Oh, went too much. Yeah. So I'm going to try just to stay under it here. Let's do the edges carefully first. Oh, stop that, don't go away. Do them as small groups, so if one goes away, it doesn't affect the others. Okay. Oh, wait a minute, that part here is not true. I went too far with those blue ones, so I need to come here. That's an important point. I have to really watch where these areas are. Oh, I don't want that to go away. Come on back. Okay. I don't know why these tend to disappear with, whoops, and I almost went a little over on that one, so I need to be careful with it. It's really easy when there's a bunch of them like this to sort of go over it. So you got to outline very carefully where these are. So what do we have? Okay. We have a vertex here. We have another vertex. I don't know why these just disappear like that. Okay. So there's a vertex here, a vertex here, a vertex here, and a vertex here, and here, and here. 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, and 7. It looks like someone anticipated that there would be 7 of them. So now we need to write them all in here, and I'll do that quickly enough, and the results quickly enough, because at this point, the calculation of this is easy. So is the graphing, if you're very comfortable with graphing. -4. In fact, none of this, not a single thing on here is actually difficult to do. You have done every single thing on here before. Literally, the only thing new is figuring out that you have a minimum and a maximum. And even that is a pretty easy thing to do. It's just the largest or the smallest. So the individual skills that you use for doing this are really easy. You have done every one of them before, and every single thing here you have done before this class, and for that matter. This one's -30 plus 12. This one's -30 plus 24. This one's -15 plus 0. Here we have -20 plus 24. Here we have 5 plus 0. 10 plus 4. 10 plus 16. Yes, by the way, on my test, I expect that you actually can do this. Actually can fill out such a thing. 15, 4, 5, 14, 26. Now, what's that show us? Our minimum value is here and our maximum value is here. Minimum value. Maximum value. Okay. Let's clean up the last little bit. Value. All right. So what we've looked at here right now are bounded regions, 4 of them, where you have these things given to you. Okay. I'm going to call that part 1 of this lesson. And in part 2, we're going to look at these 2 application problems. All right. And a little bit of something else afterwards. Okay. So this is part 1 of the optimization with linear programming.